Hello, I'm Yaroslav from Lightnovo Customer Support, and in this video I'll cover Lightnovo C SDK for Windows. If you were watching our previous videos on SDK, in them we already covered um, Python SDK for Windows, Python SDK for Linux, and C SDK for Linux. Uh, what actually I'll do in this specific video, I'll reuse my Linux code, the code developed in Linux to control Raman. I'll reuse it on Windows. I'll show which modifications have to be done, which are very minimal, and then I will start with compiling the code. Then I'll do the live demo with Raman. We'll measure the Lightnovo polystyrene sample. In the beginning, I'm attaching it to the probe. So what we have here in my working directory, it's actually this program logger.c, which is the program controlling the spectrometer, then and then logging the data to the CSV file, streaming the data to another app which is performing live visualization. And plot3d is like a helper. It's actually not using our SDK, but it would be reading the CSV files which were logged. And then we have the components of our supplied with our SDK. It's .dll file, .h file, and .lib file. And what I have on my system, I actually have GNU minimalist installation of C for Windows with MinGW 64 terminal, but our SDK also works well if you compile. The files can be compiled with Microsoft um, uh, Visual Studio components and so on. Um, I mean MSVC, Microsoft version of C. Anyways, so my terminal is using GCC, and I compile GCC logger.c minus o logger.exe, and then we have to specify our DLL. Winema.dll, enter, boom, compiled. So next step would be to compile the plot3d, plot3d.c, again minus o, plot3d.x, plot3d.exe, and that's it, without libraries. Okay, great, and we check, and the files are there. Then we need to go to launch them. We need to go to Windows PowerShell, and it's dot backslash, so it's the other way as in uh, Linux, and then we launch logger.exe. And now we see the instance of GNU plot, and it is the app is performing the scans. In the beginning, it performed the scan of the ports, then it connected to it found the port to which Raman is connected, it's COM in, then it logged it started logging the data to the file with the timestamp in the name, then turns on the laser and performing the time scans. I limited the number of the scans to 100. The exposure time is actually exactly 300 milliseconds, but it takes a bit longer due to additional delays in the program as well as system specific delays, and it looks like it is slightly um, longer delay, system specific delays, and slightly longer on Windows than on Linux. And that's actually why if you have a critical system, you have if you want to work with real-time system, then it's advised that you use Linux, not Windows. Although for some workflows, for some pipelines. You need to stay with Windows if you use Windows specific tools, which also gives some power as well. So everything depends on your application. That's why we have so many different versions of SDK, basically 4 versions covering Windows, Linux, Python, C, 4 combinations in general. So it's performed already 54 scans, but I see that the intensity was a bit low. Then I rotate the probe to increase the intensity so that we see some dynamics in the scan. So now the intensity is much higher. Let's wait for a while, and then I'll try to expose it to sunlight, and I'll point it in the direction of the sun, and we'll see how the 3D scans look like. Scan 76, 77. Let's wait. Okay, let's expose it to the sunlight, and we see a solid spectrum with a specific dips due to atmospheric absorption. Scan 91, 92, 93. Yeah, it's approximately slightly longer probably than 1 second. Definitely the performance of the same code was faster on Linux. You can watch the Linux video and you can compare. So we logged it, laser off, closed, done. Let's close the GNU plot and let's go to the folder over here, and then we have timescan file appearing, and we double click on it, and as you can see, it is there are multiple columns in the file: scan index, then we have pixel number, pixel index, we have Raman shift colon, and we have the intensity colon. And if we scroll down, what do we have here? It's like control page. Control N. We have 100 scans and 167,601 lines in the file. So let's go back to the terminal over here, and we'll use plot3d, plot3d.exe, and we supply the file name as an argument as shell argument launch. And this is what we have now. And as you can see, in the beginning we had, if you remember, we had relatively low intensity of polystyrene here. Then we increased the intensity of polystyrene. It's like from the time scan from over here to over there. And then last scans, they were solar spectrum. So I think this type of visualization, it looks really nice when we use GNU plot engine. Okay, so I actually promised to go through the code a little bit and explain what has to be modified when we port this app from Linux to Windows. And actually over here, this is the same, and the only difference is over here. Basically, this describes the difference and the fix. So in Windows, it's windows.h, so system specific, library, while in Linux and Unix it's unistd.h. And they have some differences. It's the delay in Windows is the function sleep in milliseconds, while in Linux it's usleep in microseconds. Then in addition to that, the call to external app, which was gnuplot in our case, it's popen in Linux and underscore popen in Windows. And the same with pclose. So these were the only modifications which had to be done. And as you can see, they have nothing to do with our LNMR code. Plot 3D, again the same thing, and over here it's only popen changed to underscore popen, pclose changed to underscore pclose. So I hope that this video was a clear demonstration of capabilities of Lightnovo C SDK on Windows, as well as it showed the possibility to port the app from Linux, developed in Linux, to Windows system, or the other way around in some cases. And it concludes the initial series of videos on different flavors, basically, of SDK from Lightnovo, which is Windows, Linux, Python, and C, so 4 different combinations of those. And thank you for your attention. And if you are interested in acquiring our SDK, please contact us and subscribe to our channel. Leave your comments under this video. And if you have ideas or suggestions what should be covered in our next videos on SDK, please write in the comments. And thank you again. Bye.